Year 12 End of Year Exam Paper 2 Calculator, June 2022. Question 1. The quadratic equation k minus 1 x squared plus 2x plus 2k minus 3 equals 0, where k belongs to any real number, has real distinct roots. Find the range of the possible values for k. First thing we're going to do is use the discriminant. So the discriminant equals b squared minus 4ac. We know that a is equal to k minus 1, b is equal to 2, and c is equal to 2k minus 3. Therefore, we get b squared is 4 minus 4 lots of k minus 1 times 2k minus 3. When we multiply that out, we get minus 8k squared plus 20k minus 8. We now need to factorise this to find the critical points. Therefore, we get minus 8x plus 4 brackets x minus 2. Find the critical points. So minus 8x plus 4 equals 0, or x minus 2 equals 0. So minus 8x equals minus 4. So x equals a half, or x equals 2. Because we have two real distinct roots, we want minus 8k squared plus 20k minus 8 to be greater than 0. If we draw ourselves a little diagram, because a is minus, we know we've got an upside down parabola. We know our critical points are half and 2. And we want everything to be greater than x. So we want all this part. So our possible values for x are a half less than k less than 2.
A particle moves along a straight line so that its velocity, v in meters per second, after t seconds is given by v to t equals 1.4 to the power of t minus 2.7, for t is between 0 and 5. 2a. Find when the particle is at rest. We know a particle is at rest when its velocity is 0. Therefore, Vt equals 0. We can do this on a calculator by drawing the function Vt equals 1.4 to the power of t minus 2.7. Having drawn the graph of 1.4 to the power of x minus 2.7, you can now find the zeros. Go to Menu, Analyze Graph, 0. We know roughly where the 0 is. Go to the left-hand side and to the right-hand side. We are now told that the 0 occurs when x is equal to 2.9. 2b. Find the acceleration of the particle when t equals 2. The acceleration is equal to the differential of velocity. Therefore, if we find the differential of the equation 1.4 to the power of t minus 2.7 when t equals to 2, we will have found the acceleration when t is equal to 2. This can also be done on a calculator. If we type in the differential, inside we put the equation 1.4 to the power of x minus 2.7. And outside the bracket, we put the vertical line and then x equals 2. If we press enter, we will now get that the acceleration was 0.659486, which is 0.659 to 2 decimal places. Therefore, the acceleration when t is 2 is 0.659 to 3 significant figures.
Question 3. Let f of x equal x squared plus 3 raised to the power of 7. Find the term in x to the power of 5 in the expansion of the derivative of f dash x. So the first thing we have to do is find the derivative of f of x. So f dash x, it's a chain, so multiply by the 7, the bracket stays the same. Take 1 off the power, then multiply by the derivative of the bracket, which is 2x. So f dash x is equal to 14x, x squared plus 3 to the power of 6. We now have to expand the bracket, x squared plus 3 to the power of 6. We want eventually to have the x to the power of 5 term. Because we are multiplying by an x outside, we want the x to the power of 4 term for the bracket. Therefore, if we expand the bracket using the formula, n choose r, a to the n minus r, b to the r, we know that n equals 6. We know that a equals x squared, and we know that b is equal to 3. We don't know what r is, but we will have to find it by comparing powers. Substitute all unknown values into the equation to get 6, choose r, x squared to the power of 6 minus r, 3 to the power of r. Now we will compare the powers for all the values that involve an x. So we get x squared raised to the power of 6 minus x, and we want that to equal some coefficient of x to the power of 4. So let's multiply out. So we get 2 times 6 is 2. So we get x to the power of 12 minus 2r, and we want that to be some coefficient of x4. Now we can compare coefficients. So we get 12 minus 2r is equal to 4. So we get 12 minus 4 equals 2r. So we get 2r equals 8. So r is equal to 4. Now we can substitute everything back in to get 6, choose 4, x squared to the power of 6 minus 4, 3 to the power of 4. Now we can just take the coefficients part and work them out, which gives you 6, choose 4 times 3 to the power of 4, which is equal to 15 times 81, which gives you 1,215. The last thing we have to do is multiply by 14x. So we get 14x times 1215 x to the power of 4, which is equal to 17010 x to the power of 5, which is our final answer. Question 4. Let f of x equal x to the power of 4 minus 54x squared plus 60x, for x is between minus 1 and 6. The following diagram shows the graph of f. As you can see from the diagram, we have a maximum at A, we have zeros at P, and we have a point of inflection at B. 4a, find the value of P, which is a 0. First thing we have to do is draw the graph of x to the power of 4 minus 54x squared plus 60x on our calculator. Now that we've drawn our graph, you might have to play around with the window to make sure that you can get all of your graph in. We need to find P, which is the 0 to the right of the maximum. So go to Menu, go to Analyze Graph, 0, we know roughly where it is, so there we have it. P is equal to 1.14. So P is equal to 1.14. 4b, write down the coordinates of A. Well, we know that A is a maximum. So if we go back to our graph, so we're back at our graph, now we can find the maximum. So go to Menu, Analyze Graph. We're going to find the maximum. We know roughly where it is. So left side, right side, and there is our maximum. It is at when x is 0.562. So A is the point 0.562, 16.8. 4c, find the equation of the tangent to the graph of f at A. Well, we know that the tangent passes through A. It has 0 gradient because it is at a maximum. So the equation must be y equals 16.8. 4d, find the coordinates of B. We know that B is a point of inflection. We also know that a point of inflection occurs when the second derivative is equal to 0. So if we find the second derivative, we know that f of x equals x to the power of 4 minus 54x squared plus 60x. So then f dash is equal to 4x cubed minus 108x plus 60. So f double dash is equal to 12x squared minus 108. And we want 12x squared minus 108 to equal 0. So therefore 12x squared is equal to 108. So x squared is equal to 108 divided by 12. So x squared is equal to 9. So x is equal to plus or minus 3. We know that x must lie between minus 1 and 6. So the point of inflection occurs when x equals 3. To find the y coordinate, we need to find f of 3, which is equal to 3 to the power of 4 minus 54, 3 squared, plus 60 times 3, which is equal to minus 225. So the coordinates of B are 3 minus 225. 4e, find the rate of change of f at B. A rate of change is a differential. So we want f dash 3, which we can do on our GDC. On your GDC, add a calculator page, and you want the differential of x to the power of 4 minus 54x squared plus 60x at x equals 3. So let's open the differential. X, now type in, so an x to the power of 4 minus 54x squared plus 60x, come out of the brackets, at x equals 3. Add enter. And so our rate of change is minus 156. So f dash 3 is equal to minus 156. Question 5. The sum of the first n terms of a geometric sequence is given by Sn is equal to the sum of 2/3 times 7/8 to the power of r between r equals 1 and r equals n. Find the first term of the sequence, u1. To find u1, we substitute r equals 1 into the sequence, giving us 2/3 times 7/8 to the power of 1, which is equal to 2/3 times 7/8, giving us 14/24, which is equal to 7/12. So u1 is equal to 7/12.